typically I'd love to, take time to go through and have us each introduce ourselves. But in the interest of time, we've got a lot to get to today. So we're going to go ahead and plow forward here. But there will be some time, I think, about the middle of the meeting here, as well as at the end, we can, talk a little bit more. So integrated warning teams, what is this all about? For those of you who aren't as familiar with this concept, click the button here a few times. The whole idea or the whole concept of an integrated warning team is that you have multiple different agencies, public service, either state government, federal government, local government, the National Weather Service, media folks. We all have these different different duties, but we're kind of all aligned in this singular mission. So the whole idea behind these meetings is to come together and try and get a better idea of what all the varying roles are in our messaging and our response. We have some really solid relationships with many of you. That's, I think, goes without saying, because we have at least several of you who've been willing to present on our behalf and join us here today for a couple hours. But it's always good to build on those relationships, try and get in the same space, express any concerns we have about things. I mean, we don't like the way certain things are going, or maybe there's something that you want the National Weather Service to know that would, help you do your mission better. This is a great outlet for that. And it also allows us to refine those communication lines so we can avoid talking past each other or transmitting erroneous messages that lead to confusion on the part of the public. So just a few ground rules here real quick. We certainly want people to participate as much as possible. And I will say, looking at that agenda, we have a stacked agenda today, so there's not a ton of free time built in. But hopefully, if we can get through these presentations relatively quickly, we'll have some time to talk about some of the subject that we're covering. And certainly toward the end, I always like to make myself available for those who want to stick around and chat for a little while. I'm certainly happy to do that. So there's no judgment here. Don't take anything personally. Try and stay in your lane, so to speak, within your area of expertise. Stay on topic, stay factual. We don't want to hurt anybody's feelings here, obviously. Introduce yourself when you speak. If you don't, then I will introduce you. The way we're going to probably do this is, in the past, we tried to unmute everybody and then said, just unmute yourself if you want to ask a question. I think the way we're going to probably try it this time is if you do have a question, when we get to that time frame, I'll ask you to raise your hand and then I'll unmute you individually. And that's kind of how we'll proceed. But along with that, please do ask questions. And if you think of some, go ahead and write them down, because we're probably not going to get to them right away. But go ahead and write them down. And if we don't get to them here in the session today, feel free to get back in touch with me. If you want to schedule a time, to meet, do a Google Hangout or something or other like that, totally open to that. I'd love to do that. So yeah, again, we do have a lot to cover, but we're gonna have some time to chat here. So as I mentioned, the main players in the integrated warning team structure include the National Weather Service. And our chief role there is to disseminate watches, warnings, and advisories, but also to provide along those lines decision support services that hopefully make or help you guys make better decisions. NOAA Weather Radio is obviously a big part of that too. You have the media folks that are really force multipliers of our messages for sure. They're kind of the main message conduit to the public. That's kind of where the consumption is, and generally reach a much larger audience. NOAA Weather Radio is great, but it does have a limited reach. And then finally, emergency management. You guys are the ones that are taking the action, responding to, preparing for, mitigating these disasters that happen from time to time. So again, our objectives here is all about communication, improving streams of communication, strengthening our relationships and reinforcing those, getting a better idea of what each of our responsibilities are, and ultimately, hopefully, providing a more timely, more accurate, and more consistent message for the public. Kind of already covered this. NWS role, again, it's all about our forecast, watches, and warnings are kind of what we consider to be kind of the legacy aspects of this. And then one of the more emerging things over the last several years is the decision support services that kind of tie into each of those facets as well. Because the forecast by itself doesn't have much value. It's really how we translate that forecast into actionable information that results in the most bang for the buck in terms of what we're trying to do. So that comes in many forms. We do these briefings. Obviously, many of you are on our distribution lists and get our email briefings, our live briefings that we conduct throughout the year. But we also like to serve on site when we can. COVID has made that quite a bit more challenging over the last couple of years. But there can be some leeway there. It's kind of on a case-by-case basis, but we certainly like to provide support for events when we can, whether it be virtual, on-site, or just a phone call. We're willing to do whatever it is that you guys need. And we're always happy to do media interviews. If there's a discussion about maybe the new climate normals or the seasonal outlook. We get a lot of interview requests about that kind of stuff. It's always fun to do. And ultimately, as far as the emergency management public response side goes, we're really interested in helping develop those all hazards weather plans, as well as providing insight into mitigation efforts. So where do you see yourself in this paradigm? This is kind of one of those rhetoricals, you can think about this and maybe share your perspectives as we get to one of those sharing times later on in the meeting. I just want to quickly run down a couple communication tools. Again, I've covered these in the past as well, but for those that are new, NWS Chat is an excellent tool. And I will note that, don't expect you to jot all these down. I'm going to compile all of the presentations today, as well as a recording of the meeting, probably in 2 parts. And I'll ship that out to everybody. I know some people weren't able to make it. So you'll have some reference materials to go back and look at. So don't feel like you got to write everything down. But if you're not on NWS Chat, it's a great way to connect with us, 24/7. I know several of you on this meeting are very active in chat, and we appreciate that. And we are grateful that you're willing to get on there and ask us questions any hour of the day. Doesn't matter. We're there for you. We want to be helpful. So you kind of follow the instructions here if you're interested in getting an NWS Chat account and getting signed up. There's also Interactive NWS, or INWS for short. And this is a great one for public safety and emergency management partners especially. There are some stipulations as to who can and can't get an account. But by and large, most of you on this meeting would fall into the category where you would be able to get an account. And it's really nice because you can select, any number of addresses or areas you want to get weather service alerts for. And you can even select which ones you want. If you don't want to get a particular type of hazard or alert, you can disable that. But you can either get it by email or by text message. So, for me, it's real handy to just pull out my phone. When we issued the wind advisory for our area here, I think it was yesterday, I got that alert on my phone. So really, really nice to have. Highly encourage folks to look into that. And I mentioned this earlier, but most of you are on our DSS distribution list. If you're not and you're interested in getting on one of those lists or both of them, we have a fire weather list and kind of a general list currently. It's possible that could be broken out into subcategories in the future, but right now anyway, this is kind of where we're at. But if you'd like to be added, or if you think of anybody who maybe you had a recent addition to your team, or somebody left and you got someone else coming on, just let us know. You can either use the email address there, pdt.operations@nor.gov, or the phone number there, and we will get that updated as soon as we can. All right, so that finishes kind of that section. So just wanted to give a quick, brief overview of what an IWT is. And I believe if we look at our agenda, the next topic we have is the Weather Prediction Center Winter Products and Services. And we're very lucky to have Alex Lamers here. He's the warning coordination meteorologist for the Weather Prediction Center. And Alex and I have known each other for quite a long time. He's a good guy. So I'm happy to turn it over to him. I'm actually going to be advancing slides on his behalf. But Alex, if you can go ahead and unmute yourself whenever you're ready.
Thanks, Mark. I appreciate it. Thanks for the intro there. So hi, everyone. My name is Alex Lamers, and I am the Warning Coordination Meteorologist at the Weather Prediction Center, or WPC. And for those of you unfamiliar with what we do, no worries. I'll give you an overview momentarily before we get into the main topic of this presentation, which is winter weather. The WCM role is a relatively new position at WPC. It's only been around a few years, and one of my primary roles is direct engagement with partners and external users, which is exactly what we're doing today. I love doing this stuff, so I have to thank the Pendleton office for the invitation. And please feel free to use me as a point of contact if you ever have any questions. I'll have my email address at the end of the presentation. Next slide. So let's start with a few basic facts about WPC. What do we do? And the short answer is a lot. I'm not going to cover everything today, and I won't verbally run down the entire list you see here. As I said, the focus will be on winter precipitation. WPC does all kinds of precipitation forecasting, and that extends to rainfall as well as the frozen varieties. I'll note one other thing, just out of interest. We do provide a lot of basic weather maps and contextual information, such as potential temperature and precipitation records, that serve as a sort of a foundation of the national weather story. And that includes map analysis of current weather patterns, which is a legacy that dates back to the days of telegraphs and the U.S. Army Signal Service over 150 years ago. And I will also add that we coordinate a lot with local offices around the country, like the office there in Pendleton. And we really do work as a team, even just within the National Weather Service. So that fits with the theme today. Next slide. And WPC has a large geographic focus. Most of what we'll be talking about today are forecasts for the CONUS, indicated in the thicker green box on this map. However, I do want to note WPC does provide forecast services that extend beyond the lower 48. And for all the areas you see in the red box, spanning the North Atlantic and the northern half of the Central and Eastern Pacific, WPC actually produces rainfall statements for the official tropical cyclone advisories. And finally, one thing not a lot of people know about, we have an international desk that's a partnership with USAID and the State Department to train forecasters from other countries in Central and South America and the Caribbean. And they do produce a few forecast products for those regions, in addition to research and development of new forecast techniques. Next slide. WPC is one of the National Weather Service's 10 national centers of expertise. You may be more familiar because they tend to gather more attention, like the National Hurricane Center and the Storm Prediction Center. So we kind of fit in that same category of offices in the Weather Service. And each national center has a specific area of focus with an overall mission to enable national readiness within their focus area. And all the national centers work in close coordination with local offices, as I said. At WPC, one of our key areas of expertise is related to extreme precipitation, and that extends to the liquid and frozen varieties, as I said. So many of our forecasters are dialed into where extreme precip can be expected over the next week, and that's pretty much all they do day to day, 24/7, 365 days a year. Next slide. Before we get to winter products, I did want to start with QPF, or the Quantitative Precipitation Forecast, as it serves for the foundation for a lot of the snow and ice forecasts that we produce. This is probably our best known product. We've been doing it for over 60 years now. The first QPF was issued by our office back in 1960. This is just a forecast of expected liquid equivalent precipitation, so it's going to account for any precipitation type. We produce these in a variety of time increments out as far as 7 days from the issuance time. And the QPF is just a best guess forecast. It's a large scale average. It's not intended to catch every maximum or minimum. And that's an important consideration, especially in the warm season when you have scattered storms and they can pockmark the landscape with intense but isolated rainfall. WPC collaborates these forecasts with the entire NWS field structure, so there is input from local offices and river forecast centers. And WPC QPF is available in shapefile and KML formats. Next slide. We don't have the time today to cover other rainfall services from WPC in detail, but I did want to show them very briefly here. This includes probabilistic precipitation forecasts, excessive rainfall outlooks, the newly operational extreme precip monitor, and mesoscale precipitation discussions. In general, all these products just add context to what you would get with a standard rainfall forecast by describing uncertainty and/or explaining what matters. And I'm happy to answer any follow-up questions you may have via email, or we could maybe have another presentation some point in the future. Next slide. One final note about WPC QPF. When you look over the past 6 decades, there's a clear trend of steady improvement in the skill of our precipitation forecasts, and that's good news. We are getting better, but we're not by any means perfect. So on this chart you see here, basically as you move higher on the slide, that represents better forecasts by the threat score metric. And you move through time kind of horizontally from left to right. So we start in 1960, the first year we have verification data, and we move to kind of present time on the right side of the graphic. And in recent decades, rainfall forecast skill has improved by about a day per decade. So in other words, a forecast issued 3 days in advance today has roughly the same skill as a forecast issued a day in advance in the late 1990s. And our forecasts do tend to verify much better than any individual computer model and slightly better than the most skillful multi-model blends. Next slide. So let's pivot now to winter weather. So we have a relatively complicated process that you see along the top to generate internal snow and ice forecasts. That's all done internally, and these internal forecasts are used to help drive our probabilistic forecasts and for coordination with local offices. So the official snow and ice forecasts you see from the National Weather Service come from local offices. Those are coordinated with WPC. So if you look on the internet, you're not going to find a WPC snow or ice forecast specifically, but just know that we're all talking and working together on that process. What we do with our forecasts is that they become the mode of the winter ensemble system that we run in-house. So all of our probabilistic products that you see and that we'll discuss here momentarily incorporate some human judgment. They're not purely automated products. And on the WPC website, you'll see the probabilistic products that fall out of this process. So that includes PWPF, our probabilistic winter forecasts. And a lot of local office sites, you'll see a higher resolution version of that, but they're basically the same. And the winter storm outlook. And then we're also developing a probabilistic winter storm severity index. That's not public yet, but it is on the way. So have a multi-pronged approach pretty soon of a lot of probabilistic information for you related to snow and ice. Next slide. So to start with, we provide basic probabilistic data for certain accumulation thresholds of snow and ice for the first 3 days of the forecast. And we kind of have it in this national scale interactive map on our website. Like if you want to look outside of your local area, this is an easy way to do that. Otherwise, the local offices provide a lot of this information. And these are presented as both percentiles and probabilities of reaching a variety of amounts, like the probability of 4 inches of snow that you see here. And this is going to give you a sense of the range of reasonable possibilities for snow and ice accumulation across the lower 48 states. And as I just said, WPC forecasters influence the probability distribution with their internal snow and ice forecasts that are coordinated with the local offices. And because forecasting the precise amount of snow or ice is inherently uncertain and subject to a lot of different factors, probabilities are often a far more reliable way of communicating about winter accumulation forecasts. Most people still want to know what the best guess is, how much snow are we going to get? But our experience suggests focusing too much on an exact value can mask just how much uncertainty there is in any given situation. And probabilities do help. Next slide. So the question is, are the probabilities reliable? And we look at reliability diagrams to evaluate this. So this is verification data from last winter. And we're basically looking here to see whether something happens 20% of the time, for example, when we say it will happen 20% of the time. If it does, then you have a reliable forecast. And on the left side, you'll see the snow probability verification with the 1 inch threshold in red, 4 inches in green, and so on. And on the right side, you'll see ice verification at the 1/10 of an inch threshold specifically. And a perfectly reliable forecast would track along the thick, bold black line on each graphic. Underneath that line, you're a little overconfident, and over that line, you're a little underconfident. And you can see the probabilities are fairly reliable overall, particularly at the lowest and highest values. So kind of below 30% and above 80%. However, so we are slightly overconfident in the middle. In other words, when we forecast around a 60% chance of a certain snow amount, it occurs slightly less often than that, maybe around 40%. However, overall, that's pretty good. This has improved in recent years as well. And the solid reliability at either end of the distribution does mean that, for instance, the 10th percentile forecast would be a reasonable baseline for at least how much snow or ice you should expect. And the 90th percentile would be a reasonable worst case scenario. And that can help you understand the range of possibilities. Next slide. So here's a quick example showing potential snowfall from a winter storm in Wyoming. And the area around Casper is forecast to get around 10 inches of snow. But the 10th percentile is way down around 4 inches, and the 90th percentile is around 15 inches. So there was a lot of uncertainty in this case. And you can use percentiles like this to give you some reasonable goalposts and expectations. 80% of the time, the actual snow amounts will be in that range. For this particular storm, Casper actually received almost 13 inches of snow, so we were really getting close to the 90th percentile there. Next slide. Of course, what constitutes a meaningful amount of snow will vary across the country. So 4 inches of snow in Atlanta is probably going to be a huge deal, but 4 inches of snow in Buffalo is probably going to have a lower impact overall. Local National Weather Service offices have set warning thresholds across the country, and when those thresholds are expected to be met, they will generally issue a watch or a warning. And we leverage those thresholds that vary from county to county across the US for the Winter Storm Outlook, or WSO. And the WSO takes a slice through the probabilistic data sets at the warning thresholds for snow and ice, and it provides the probability of reaching those values. So I have an example here from the March 2021 blizzard earlier this year from the Front Range. And you can see the high probabilities, over 80%, indicated a significant winter storm was very likely in a populated corridor. So the WSO is available as a shapefile and a KML file, and we do have an interactive website as well. Next slide. Another winter probability product that we provide is the Winter Weather Outlook, issued for longer lead times for more than a few days in advance, day 4 to 7. And the technical definition is the probability of 1/4 inch of liquid equivalent for snow and sleet precipitation. That's a mouthful, and it's really hard to translate that for the average user. So we generally say it's the probability of about 3 inches of snow, give or take. On average, it'll be about that much. And it can be difficult to translate the technical definition, so we just say the probability of a few inches of snow. Some people refer to it as the chances of plowable snow. How realistic that is in certain parts of the country, I don't know, but we have heard that. But 3 inches of snow is generally enough to give you some impacts. So this is generally a probability of some impacts from snow. And the verification does show these probabilities are quite reliable as well. And we have KML files of these. Next slide. And the last winter-specific product I'll show you is the Winter Storm Severity Index, or WSSI. It's an exciting new tool that forecasts the general level of potential impacts from winter storms and their spatial distribution across the country. WSSI is produced for the first 4 days of the forecast, and I'll show you some extra context and examples momentarily. Basically, WSSI converts the official best guess National Weather Service forecast for things like snow, wind, and ice that you already get from your local Weather Service office, and it converts it into an impacts framework. It's more comprehensive than other products that are based around a single threshold or weather type, like Winter Storm Outlook. Please keep in mind it's not forecasting specific impacts like the closure of a specific business or school. Instead, it's intended to give you a sense of the general potential impact level to society. And it's important to emphasize the word potential when talking about impact forecasts, as actual impacts are going to be affected by societal response. So that comes down to highly complex mix of decisions from the individual level to your level in government and media, businesses, organizations. So that it all factors in, and that's why we say it's not forecasting specific impacts. Next slide. The overall WSSI level is composed of 6 different winter weather hazards shown on this slide. On our website and with the GIS files, you can view the overall WSSI, or the impact level, for one or more of the individual components. The maximum value from the individual components you see here becomes the overall impact level. So let's say all of these are showing like a limited impact, except ground blizzard shows major impact. Well, then the overall WSSI is going to show a major impact as well. Snow amount and ice accumulation are relatively straightforward. They're related to the standard snow and ice forecast that you see. Snow load is meant to describe the potential weight of the snow and potential impacts to trees and infrastructure. And blowing snow and ground blizzard are more closely related with blizzard conditions and a combination of snow and wind. Blowing snow is when it's actually snow is falling out of the sky, and ground blizzard is related to strong winds over pre-existing snow. And flash freeze just describes the potential for quick forming ice from rapid temperature drops. Next slide. So WSSI does account for some non-meteorological factors in the impact level calculations. Urban areas are used for the ice accumulation and snow amount components to give it a 25% boost to raw impact values, and that's eventually converted into the impact category. Land use is incorporated into the blowing snow and ground blizzard components to decrease impacts for areas with reduced wind, such as dense forests and areas with high density of buildings. And finally, forest type is used in the snow load component because coniferous trees can usually handle more snow than deciduous trees. So overall, the meteorology is going to drive your impact levels, but these are important nudgers that are accounted for. We've received comments and feedback on other non-meteorological elements that people would like to see, such as rush hours or days of the week. And we've discussed those, but they're not currently incorporated into WSSI. So maybe more on that in the future. Next slide. I'll show you two quick examples of WSSI in action. The first one here is a snowstorm in West Texas, and the standard forecast here called for a swath of 7 to 9 inches of snow, shown in yellow shading on the left side, which was converted into a swath of major impact in WSSI over parts of West Texas. And this makes sense if you think about it logically. That much snow in Texas would be very likely to cause significant disruption. Midland only averages 4 inches of snow a year, so they're forecasting double their annual average. And WSSI leverages a dense network of snowfall data over the past several decades, downscaled in areas of terrain like in the West, to help answer the question, how unusual is this amount of snow in this part of the country? So it's basically aware of facts like that Midland annual average snowfall, what their snowiest storms were, and this can even account for differences in snowfall patterns within individual counties. So it's more precise than the winter storm outlook in that respect. Next slide. And the second example here is from a ground blizzard in the Northern Plains. And here you can see the gradient in impact levels over Minnesota, where the WSSI quickly drops off due to increasing forest cover. Remember, that's a non-meteorological component we use. So this makes WSSI more sophisticated than a simple calculation using something like just snow and wind and a simple decision matrix. And so this is a good example of WSSI, I think, because you need to consider, are you interested in the impact level at a specific point, or are you interested in the impact level for a point in a surrounding area? For example, people commuting to a central location. Sampling the WSSI at a specific point may not be reflective of the overall impact level from the county or the region that that point is embedded in. Next slide. A few final reminders on the Winter Storm Severity Index. Again, it's not a specific forecast for specific impacts. A moderate severity does not mean schools will have to close. It represents a general level of potential impacts based on NWS forecast information. And be sure to use WSSI in context with other NWS forecast and watch warning products. It's a powerful tool, but it's still just one data point. And we like feedback on that. If you see an event where we say there's major impacts and it's not a major impact, that's good to know about. So that sort of feedback is great. And you can either send that to me or send it up through a local office like the one there in Pendleton. And remember that WSSI does not account for conditions that occurred prior to the issuance time. So if a winter storm is ongoing, WSSI may be artificially low if half the snow has already fallen. So it's best used as a tool in the lead up to a storm. Next slide. And one last thing I'm going to mention before I wrap up, the day 3 to 7 hazards outlook we issue from Monday to Friday. We're looking at ways to increase the tempo to 7 days a week, but it does have precipitation hazards. It's not just limited to that, though. It's a depiction of areas where all weather-related hazards are possible at 3 to 7 days of lead time. So if you're in an outlined area on this outlook, it just means the forecaster has judged that, for example, heavy snow is possible in your area on the specified dates. Next slide. And I covered a lot of ground there, but if you take only a few things away from this presentation, I would emphasize that WPC is really focused on precipitation. We want to get it right on the extreme rain and snow and ice events. And our product suite has evolved to be more probabilistic and impact focused, and that's probably going to continue. Feedback is vital, so please reach out if you need anything or have any comments. And my email address is here for feedback if we need to move on to the next presenter. Thanks.
Thank you so much, Alex. And just a wealth of information there. You know, I was sitting here thinking as you're going through all that material, you really could devote probably 1 full hour to all the different things that WPC does, not just for winter, but also on the liquid side. You know, we have a lot of rain on snow flood concerns here as we move into spring. And I'm just envisioning how useful that could possibly be as we get into like mid to late winter time. So I might be reaching back out to you, Alex.
Yeah, that'd be great. Yeah, anytime you're happy to do that, we can give a presentation. And if anybody here is interested in learning a little more about anything that I covered or I didn't have enough time for, just feel free to reach out. I'm happy to help.
Alex, I know you're in Eastern time there, so it's the end of the workday for you, but we may have time for just one quick question if anybody has one. Just hit the raise your hand icon. I'm not exactly sure where it is, but it should be a little icon. It looks like a hand, and I can unmute you and you can ask the question. I'm not seeing anybody, Alex, but I had one comment for you and then one question. I know you're talking about WSSI and taking into account things like vegetation, tree type, land use, that kind of thing. One thing we noticed out here is the topography, and that the mountain peaks stand out. And I didn't know if that was something that had been mentioned to you all before as well.
It's a good thing to mention, actually, because right now, if you look at it live, the current data, you'll see it standing out because of blowing snow potential at the very tops of the peaks where they're a little more bare. It's above the tree line. And the snow right now, the snow amount component is actually not that significant. It's saying that basically the snow that you're expecting with this event is not terribly unusual. But when you get to the tops of those peaks, you're probably going to get really strong winds, and you're also going to get a combination of snow and wind. So yeah, if you're looking at it there, you can flip over to like snow amount component at the very top in the tabs above the days. Yeah. So you can see it's mostly yellow, minor impacts. But if you flip over to like blowing snow, you'll see it pops out at those mountain peaks. So you will notice things like that depending on the specific location you're looking at, the specific grid point you're looking at. And the interactive map helps you really tell what you're looking at. But we have had conversations about like, okay, the top of Mount Hood or something, like, is anybody up there? Like, what is the impact exactly? And should the impact level be capped in areas like that? And it's really hard. You're making judgments like, should you assume that there's nobody there or not? So we are talking about it, about ways we can improve it in areas of the West where maybe you wouldn't necessarily have a lot of impacts at the highest elevations.
Yeah, that's a really good point. I suspect that some of our avalanche forecasters on the meeting here would say, yeah, don't cap it, because there are a lot of recreational folks that get out there and can get caught in these conditions, if they don't know what's coming. The other question I had for you was actually on your skill scores for precipitation. I'll go back to the slide here. And your skill score there is for 1 inch. And, I think it's for 1 inch if I'm reading it properly, right? 1 inch threat score.
It is, yeah.
Yeah. So have you run this same kind of verification for lesser amounts? Because, getting an inch of precip out here, it can happen, but it's fairly uncommon unless you're like west of the Cascades.
Yeah, it's a good question. So we do run it for other amounts. I think we have a longer record for a 1/2 inch and 2 inches as well. It doesn't extend back quite as far. The reason I used an inch here is because we have that data going all the way back to 1960, so it does show a long-term trend. But
okay, excellent.
The trends in recent years are pretty similar for other amounts as well.
Great, awesome. All right, Alex, I really appreciate your time again. I know you've got home stuff to deal with there, so I'll let you get back to it. But definitely, if anybody has any further questions, Alex's contact information is right there, and I'm sure he'd be happy to hear from you. And Alex, I'll be following up with you on a possible future presentation.
All right, thanks.
All right, you're welcome to stay as long as you want, but I get it. You got stuff going on. All right, so let's move on to our next presenter. We are on to Ed, our Science and Operations Officer, who's going to be talking about probabilistic forecasting and messaging for winter weather. Ed, you can unmute yourself when you're ready.
Thanks, Mark. Hopefully you can hear me. So I'll let you drive and
I can hear you good.
All right. So thanks, everyone. My name is Ed Townsend. I'm the Science and Operations Officer here. Coming on, it'll be 2 years once we get into the next spring. So I'm pretty excited having now get to go through my second winter. So this talk will be kind of detailing some of probabilistic forecasting terms and messaging, as this is pretty much a shift in our operations and how we deliver our information and how we communicate with you all. So I wanted to kind of cover around some of the differences and changes that is coming with this shift in operations as we move towards a probabilistic world. Next slide. So we had a pretty noteworthy update this fall that is front and center when it comes to summarizing our organization's purpose. Specifically, we added the words impact-based decision support services, or IDSS, to our mission statement this past October. And this is because IDSS is as much a part of our mission as forecasts and warnings, and it is essential for us to be successful when it comes to the protection of lives and livelihood. So why we want to, provide probabilistic services is because we ultimately believe that's going to help us build a weather-ready nation, and that involves readying individuals, communities, and partners for extreme and hazardous weather. And this transformation really has been underway for a long time, and it has been an iterative process all the way back to 2011, I think, when the Weather Ready Nation Roadmap was created. The biggest takeaway from that plan was to shift from simply a product-focused services to one that goes beyond that with interpretation and consultation. Fortunately, we can do this shift because of advancements in our field, from satellite data, where we have now 60-second data at 1.5 to 2 kilometer resolution, to really high resolution model guidance down to 3 kilometers. So the chief way for us to work towards this goal is to communicate more effectively than we have previously. So decision makers, our partners, our stakeholders, you all have as much lead time as possible for potentially high impact events to allow you, and then time to plan and prepare. And this comes in the form of better specificity and better delivery of the risks and threats. And when it comes to the delivery, it entails in part through forecast confidence and probabilistic information. Next slide. So let's take a look at a traditional forecast versus an example of a higher level piece of forecast information. So on the right, at more the traditional level, moderate snow is possible overnight. And as we improve our communication and add better specificity, we can better service and better provide a delivery of service. So the next tier would be a 60% chance of snow tonight, range of 1 to 4 inches. Until finally, our ultimate goal, not only can we say moderate snow is expected between 2 and 5 p.m., but we can say most likely between 1 to 3 inches, a reasonable worst case, 1 in 10 chance it exceeds 5 inches, visibility as low as a half-mile in times, and a snowfall rate of 1/4 to 1 inch per hour. So again, some other examples would be, patchy freeze and drizzle this morning, whereas in an IDSS forecast, we're going for freeze and drizzle between 2 and 5 a.m. may form a thin layer of ice that can cause very dangerous travel conditions, and then some preparedness actions like slow down, don't use cruise control, and keep your distance from other vehicles. So that's really the main point in this progression of weather information, is providing better specificity, impacts, and numerical uncertainty where possible. Next. And when looking at this head, when it comes to uncertainty, it really comes down to confidence, which is at the center of our decision support services, not uncertainty when we communicate. And the reason we do that is because uncertainty is more of a scientific term, and it really isn't congruent when it comes to clear, plain language. We use uncertainty often to describe model spread or when solutions diverge, or outside of our community, we refer to a confident when you are in the forecast or potential outcome. So the general public can be confused by it, as it can be misinterpreted as we don't know. Thus, we try to translate uncertainty into confidence, and we use forecast uncertainty with forecast confidence pretty synonymously with each other. Ultimately, it comes down to that at the end of the day, uncertainty is a reason to act, not a reason not to act. So that's something I want to get across. And you can kind of see here, when it comes to our IDSS briefings that we send out to you, you can find that the confidence information is located right at the last column on the right-hand side. And we try to provide some numerical information or estimate of probability or of our confidence with it in a percentage. Next slide. Now, alongside forecast confidence, when possible, we are starting to communicate direct probability information with a numerical estimate, and that starts with a probabilistic forecast. So a traditional forecast is one that we have commonly done for the most part outside of the probability of precipitation that you see on our main page when you look at any of our 7-day forecasts. Generally, our forecasts are pretty categorical, and they have one of two probabilities, 0 and 100%, wherein the event will or will not occur. Meanwhile, a probabilistic forecast can take on many different forms and is indefinite. And ideally, it is objective and comes from some quantitative means rather than subjective means, but that too has some value. Specifically now, we want to provide information that is more informative and is quantified in probabilities. So by giving you numerical uncertainty information, you can make better decisions and have greater trust in the forecast. This information will likely come in two different flavors or two forms. One, a threshold probability, either a chance of exceeding or the chance of reaching or being less than some threshold value, or it can come through a interval or range to provide a better depiction of the range of possibilities, where the observed value will hopefully fall within a specified range. There are some notes to be mentioned with probabilistic forecast. One, every forecast has uncertainty, but now we just want to give you the error bars, and we can do this providing, a range, a reasonable range of possibilities, and by quantifying the likelihood, or at least by providing a worst case, most likely case, and a best case scenarios. Kind of goes back to the goalposts as Alex spoke to. It is important to remember there is no clear right or wrong answer in probabilistic forecast. Sometimes the unlikely event at 20% happens, and to be fair, it should happen, hopefully only 2 out of 10 times. Next slide. So to really kind of take this home, I want to show you these two studies. Here are two studies that show the difficulty people have in interpreting words, specifically words of estimated probability. The main item to see here is that words matter, but without context in the form of numbers, people interpret things very, very differently. Here on the left is a study from the University of Oklahoma. Possible is interpreted quite differently when it comes to the percent chance of it occurring, with 2 evenly distributed peaks in the distribution center on 25 and 50% when it comes to interpretation. This poses a significant problem when communicating the forecast to this range of interpretation in that lower graph on the left-hand side. Now, this is not just a problem in our field, but in others as well. On the right-hand side is a CIA study dating back to 1977. In this CIA study, they found a wide range in how probability terms were perceived among different NATO officers, with each dot being a numerical uncertainty the NATO officers were assigning to a given verbal expression. So you can imagine some NATO officers, when they heard the words likely, can mean anything from 30% to 80, 90%. That's a huge deal. So the CIA director at the time who created this study was one of the first to recognize problems of communication caused by imprecise statements. Unfortunately, this can still be seen due to imprecise and unqualified probability terms being used in our own field. And as the CIA found back then, and other social sciences work has shown now, this promotes miscommunication, which can lead to decision-making that might not be ideal or even inappropriate. So let's try to now avoid this by making the shift to communicate the numerical uncertainty directly. Next. So some examples now. So here is a snowfall example, and this is something we do show on the web as well as we include in our decision support emails and our webinars. On the left-hand side is a chance of exceeding 1/10 of an inch of snow. So using as much ensemble guidance as we have and a lot of different forecasts, we can try to create a probabilistic forecast that is reasonably calibrated. So we can see here a percent chance of exceeding 1/10 of an inch or more for an event that's going to occur later, earlier in the month. On the right-hand side is our reasonable worst case scenario with your high-end scenario displayed on the right. A high-end amount here we define as 1 in 10 chance of occurring or 10% of the time. Next. Here is another example of some of the graphics that we're working at. So this is the 24-hour amount of rainfall or snow melt, so liquid equivalent, next Wednesday based on the forecast information from Friday this past week. On the right-hand side is the chance of exceeding 0.2 of an inch of rain or snow melt. And on the left-hand side, on the bottom left, is your interval range, where in this range, we're looking at 80% of the time, the amount of rainfall displayed at a location falls between this given range. So the idea is, again, we're trying to characterize and frame the setting, so to speak, so you can get more information than a simple number. Instead of just saying, the likelihood of the forecast is 0.09 of an inch at Pendleton, we want to say, well, we can have a range, 80% of the time it's going to fall between 0 and 0.3 of an inch. And, that range will increase or decrease depending on the confidence or uncertainty in the given forecast produced by the Weather Service. Next slide. Here is another example of a probabilistic product. This is a point probabilistic product produced actually by the River Forecast Center for the Umatilla River at Gibbon, upstream of Pendleton. Note, this is pretty current, so we are starting at a very low stage, which isn't surprising considering our drought situation. And there has been no change in our drought across Northeast Oregon. So most stream flows in Eastern Oregon are low, and here near Gibbon on the Umatilla, it's more or less the same story there, with the river stage less than the 10th percentile based on its period of record. I guess the main point in this example is it shows that there is a 5 to 10% chance of exceeding 5.5 feet between November 19th and November 26th, which is the third bar in from the left. Here it also shows there's a 50 to 75% chance of reaching and exceeding 4 feet between November 26th and December 3rd, the fourth bar in from the left. So again, this is a different form of information. Instead of just showing you a river gauge or a hydrograph forecast for the rivers expected, we can try to give you more information to guide decisions. So if we had, for instance, a flood, we could kind of give you more information so you can take a better action, prepare to take action depending on the forecast. Because maybe your threshold to take some certain preventative action happens when a moderate river stage is being met or higher is being forecast. Next slide. So actually, Alex did talk about this already, but this is again another example of a probabilistic forecast really at its core. So this is the excessive rainfall outlook produced by the National Weather Service Weather Prediction Center. Again, their primary functions are they're using their expertise for accumulating precipitation forecasts, highlighting heavy rain, heavy snow in areas with potential for flash flooding. And they provide these excessive rainfall outlooks, which are comparable to the convective outlook by the Storm Prediction Center. All of these outlooks relate to the chance for exceeding flash flood guidance within 25 miles of any point. And all we mean by flash flood guidance is that's the amount of rainfall over a short duration that would cause flash flooding or bring rivers and streams up to bankfull conditions. And usually that occurs when you have a heavy rainfall that exceeds the ability of the ground to absorb it. And we're talking a very short time period, generally less than 6 hours. And this heavy rainfall can stem from intense convective rainfall rates from thunderstorms or rain that results from persistent lift owing to mountain barriers, which is a common scenario in the Pacific Northwest since we have so many of them, whether it's the Cascades or the Blue Mountains. So you can think like atmospheric rivers in the cool season. So this risk category is driven by heavy rainfall and the overall weather pattern, while taking into account other factors such as soil moisture and stream flow. I guess one of the most critical points with this excessive rainfall outlook is, it doesn't mean the rain will be of marginal intensity when there's a marginal risk of excessive rain. It really just relates back to that probability of 5 to 10%. And keep in mind, this is really excessive rainfall outlook and doesn't take into account other types of flooding, such as rain on snow, snow melt, or ice jam related flooding. Again, this can all relate back to odds. Flash floods are pretty rare, and the likelihood of flash flooding happening on any given day is probably less than 1%. So if the climatological risk is 0.5% or 0.5%, then a 20% probability means that the risk for flash flooding is 40 times larger than normal, which, that could be a pretty big deal. And depending on your thresholds, whether your interests are media or emergency management, that could change your opinion on how you prepare and look ahead to make your decisions. Next slide. So this is kind of just an example for the excessive rainfall outlook from the Weather Prediction Center and how they express their information as it relates to the risk of excessive rainfall, both probabilistically via percentage, as well as categorically And this table kind of helps visualize it. And I find it really helpful too, because there's that part, second row from the bottom where you can see the flash flooding, no flooding grid point section, to kind of look at the risk for flash flooding and the aerial coverage as each category increases from marginal to high. Next slide. Some final thoughts. This is really a growing process, and every year we're kind of fine-tuning it. How do we improve our support services when it comes to emails, written communication, as well as just verbal and communication over video? And now all this information is suited to be presented in a probabilistic format right now, either because the data isn't there yet or the method to communicate isn't right yet when it comes to from a design standpoint. So one thing you will see sometimes is the challenge in communication as we move, and you got to remember that we'll try our best, and what really helps us is your feedback. What questions or comments do you have regarding probabilistic forecasts? We need to know what works and what doesn't work, because it is a team effort, and it's really the one way for us to improve our services is as we go through these growing pains, what works and what doesn't. So some questions to consider before we hit the break, is, do you prefer a certain specific form of probabilistic information than others? Range versus, say, a chance of exceedance? What probabilistic thresholds would prompt you to spin up and take action? So that's a pretty open-ended one. Another approach for helping express uncertainty would be to provide alternative scenarios, along with some goalposts. Do you have any thoughts on that method? So that's all I'll part with you guys, and I'll give it back to Mark.